There we go. All right. All right. Welcome. We're officially live. This is another Delta RS development meeting. The agenda or what I would say, a tentative agenda would be I shared in our Delta RS Slack channel. And it's just, I was thinking we could go through, Neville could just talk through some of the recent changes that he has had merged around the writer support in the arrow crates. I wanted to discuss a little bit and just get on the same page around what our, let's call it, roadmap or plan should be for releasing crates with Tokio 1.0 as a dependency. And then after that, I'd love for Chris to share his screen and sort of walk through some of the writer changes that he's been working on. Does that seem reasonable?
Sounds good.
Yep, sounds good.
Yep.
All right. Mr. DePaula, you're up first.
Okay. Thanks, I'll start. So there hasn't been that much activity from my side in the last 2 weeks. The main thing that we've done, we matched the Tokio 1.0, what's this? The update to dependencies. There was some issues with the IPC integration tests failing, but QP helped out, and then we found a solution for that. We merged that. I'm looking at supporting the 2.6 version of the paquet format. There's a bigger issue in the sense that the Rust writer only supports the legacy format, but because of backwards compatibility, even if you're writing like with the version 2 of the writer, you still sort of end up writing valid stuff, but it's actually really version 1 of the stuff. So I've been doing a lot of exploratory work on the paquet repository, also looking at the paquet MR, the Java equivalent, and the C++ equivalent, to see how we can pave a way of giving us proper 2.6 support. So one of the challenges we face with, for example, 2.6 support is that I think there's two types of, two data types that we actually don't write correctly. So we sort of lose precision if you're writing nanosecond precision timestamps, because the old version that supported that was that 96-bit integer, which is quite messy to work with and has been officially deprecated for a few years now. But to get proper timestamp nanosecond precision support, I need to do a bit of plumbing around the separating the formats between version 1 and version 2. I've got some rough work that I've been doing, but it looks like it's leading me down like a long path. So early last week, I was looking at how I can sort of separate the work better, so that I can be able to deliver it in chunks without disrupting anyone. I'm still thinking about it, but I think, yeah.
Sorry to interrupt. The work that you've done thus far, have you been able to set up like a Spark reader to validate the data that's being written thus far?
Yes, I've done that.
Okay,
I've just done it locally. Yeah, I'm doing it with what's this? Oh, I keep forgetting what the PyArrow. Sorry, I'm doing it with PyArrow and PySpark. I'm just using notebooks. So I write stuff in Rust, and then I test them in both of those too. That's where I picked up that there's some compression formats that we're not supporting correctly. I opened Gyrus for that, but encodings look fine so far. It's just that the version 2 write stuff is not currently accurate. There is some discussion happening on the paquet repository where they want to document core features, and by that they're looking at what every implementation should support as a minimum, because there's a lot of exotic stuff, especially when you go beyond the 2.6 of the format, like 2.7 and 8 introduced encryption, which we don't need, but they want to sort of standardize. Because what I saw actually, I opened a pull request in the paquet format repositories suggesting that we adopt the arrow intervals as part of version 2 of the format, because version 1 has intervals, but version 2 doesn't have intervals. So if you try to really support a version 2 writer, it sort of becomes a bit muddy, in the sense that you're effectively using the schemas of both version 2 and version 1. So I started a discussion there, or I opened a pull request because I noticed that even though we had version 2.8 of the format, a lot of the writers still use version 1 by default, which I guess if everybody's doing it to try to be conservative, not to break changes. But the downside of that is that the Rust writer only really supports version 1, and reading version 2 files back in the Rust writer won't give us the correct results. So I've been doing quite a lot of exploratory work. I haven't done anything concrete that I can say I'm opening a pull request on this. The other thing that I've been working on, this is relevant to you, Christian, so it'll be interesting to see what you've done so far on the write support. Is remember I mentioned that there was that pull request that somebody had started where we were trying to be able to write data to a bunch of to a vector of bytes instead of a file. So I've been working on that. I'm trying to abstract it out into a trait, but I picked up that I actually missed this. There was a pull request a few months ago where somebody created an in-memory data
Writable
source.
cursor, right?
Yeah, the writable cursor. Yeah.
Yep.
So I'm
I found
wondering
it.
whether we could. Oh, okay, cool. Yeah, I was wondering whether we could use that and what the gaps would still be, because I think from a writing to block storage like S3, we need to be able to split the file into multi-parts. So I'm wondering how we'd be able to do that.
Yep. I think when we get to my section, we can talk about that a little bit.
Okay, cool. Yeah, I think that's it from my side. In summary, I haven't done much work. There's been like personal stuff that I had to deal with, so I wasn't even like at work for about most of last week.
Gotcha. So unfortunately, I got a meeting scheduled at 9:15. So it'd be great if y'all kept chatting. Let's talk about Tokio 1.0 real quick.
Okay.
And then when I have to jump to my other meeting, I'll just leave this window open, and if somebody will ping me in Slack when it's time for me to close the meeting, because I don't know if I'll disconnect the stream if I leave.
Okay.
So Tokio 1.0. I guess my first question on this, I saw the arrow code get merged. QP and I merged the code into Delta RS. From the arrow release standpoint, Neville or QP, how long do you think it's going to be before there's an actual, arrow crate that is pushed to crates.io with the Tokio 1.0 dependency?
Probably a long time, but that
3 months. Yeah.
It's not just the arrow crates. We're also using Azure Crate, which also does not have a release in crates.io. So that's another problem that we have to deal with.
I didn't know that. That's a bummer. Ben will be disappointed. It sounds like either way we're in unreleased crate territory for a few months.
Yep.
Does that Neville, does that Tokio 1.0 thing in Arrow, does that mean that there would be a major version bump, or are we just waiting for an incremental version?
Yeah, it's going to be incremental. So we don't follow Semver. The next version of Arrow will be 4.0. And then that'll be in about 3 months from now.
Gotcha.
It's from 3 to 4, right? So
yeah, we're going from 3 to 4.
Does that mean that there's a window where there's going to be potentially more unstable things that come in to Arrow? Or should we be able to pin to where we're pinning from a version in Delta RS and be pretty safe there?
I think we should be able to pin. Yeah, we should be able to pin to a version, and then I think what I can do from my side is, if there's interesting work that's been done on, especially the Parquet side, which is relevant for us, I can submit a pull request just updating the what's this the pin versions.
Okay. that works for me.
Okay.
And the QP for the Python binding, I mean, my understanding is we're just building the what are they called, many wheels?
Yep.
Ourselves. It kind of doesn't matter if we're pinning.
Yeah, that doesn't matter for Python. It only matters for crate.io release.
And it's a bummer, but I don't think it actually stops us from doing anything.
Yeah, the downstream users who can use Git hash as well to pull in the dependency, so I'm not too worried about it.
I don't know if we, aside from maybe Christian, I don't know if we have too many downstream Rust crate only users right now.
Yeah, that's why I'm not really worried about it.
All right. If there's no other questions around Tokio 1.0, maybe I'll hand it over to you, Christian, and I've got to jump to my other meeting, so I'll mute this window.
Okay, sounds good.
And I'll talk to y'all in a bit.
All right, I'll do my usual fumbling to find my screen share. Got it. Okay, so I did just actually, let me post this in the channel real quick. I did just submit a draft PR based on the code that I'm gonna share. Where's the chat? There it is. So draft PR here. So basically what I'm doing right now for the initial write support, and what this draft PR is trying to do is just, as far as the core code in Delta RS goes, it's just trying to add a very basic transaction API. Most of the interesting code in the PR is actually all tucked into this one big test, which that test is really includes a lot of meat around that includes a Delta writer struct that would use this transaction API. And the reason I did it this way is, I feel like we probably have a lot more iterations to do on the actual Delta writer struct itself before it actually becomes a part of the Delta RS code base. And I think for my needs, I don't even need it to. For our primary use case that we're trying to solve, I will happily just keep this Delta writer completely outside of the Delta RS code base. But it's nice to use it in the test just for kind of validating that the transaction API that I've come up with meets my needs. And as a Rust noob, it's really good for me to use this to work out all the ownership things, which ownership is something that I'm not a master of yet. So what I have here shown on the screen is is the test that I've called write exploration. And it includes like I said, a Delta writer struct for writing arrow record batches, as well as interacting with the transaction API. So in the main little smoke test I'm using, I initialize a Delta table and a Delta writer. I create a little vector of JSON values, write out my record batch after initializing a transaction. And then after writing out my record batch, I create an add action for the Delta log and commit that. And then we do a little update as well. And the update basically changes some values, writes an add and a remove to a different transaction, and then commits that. So everything in this test file is a very naive implementation of writer support. But I think one of the things that is really interesting to look at specifically is what Neville mentioned a moment ago, which is that in-memory writable cursor. I actually think that So this is the implementation in Arrow. I actually think this might meet our needs in a very complete way. So we might not need any further work. But you guys feel free to tell me if I might be wrong on that. My thought is this is exactly what we want. So we would want to have this. Hang on, I gotta silence Slack. It's killing me. All right, that's better. Okay, so ultimately well, let me start with what I'm doing right now. At the moment, the naive Delta Writer API that I have takes in a Delta table metadata object in a record batch, instantiates one of these in-memory writable cursors, and writes it determines what the next data path to write to Delta is, writes everything to the cursor first, plucks off the size, and plucks some of the metadata out of the record batch as well, such as the partition values, and then writes it to storage and creates an add action. Ultimately, I think what we would want to do here is to rearrange this so that we could write multiple record batches with and basically hold that cursor and writer as owned properties of the Delta Writer struct, and basically on flush is when we would write to storage and create the add action instead. So basically, I think that's the missing bit that I have, but I feel like the in-memory writable cursor itself is exactly the struct we need to do that. I would just need to figure out how to rearrange this so that I can own the cursor and own the writer across multiple calls from the calling context, if that makes sense.
Yeah, that does. And then I think when you do that, one of the benefits becomes that you'd be able to potentially, after writing each batch, check the size of the cursor's data.
Exactly.
And if it's big enough, or I'm not sure of how what the limits or thresholds are with writing multi-part files. So if it's, let's say for example, your limit is 5 megabytes, and then you find that what you've written so far is close to that 5 megabytes, for example, then you'd probably close the file, write the footer, and then write it to storage, and then when the next batch comes, you sort of clean the data in the writer, so in the cursor, and then start from there. Yeah, I think that could work.
Cool. Yeah, that's what I'm thinking. I tried a little quick pass at it, and because of my Rust noobness, I just couldn't figure out all the ownership details. But I feel like this is something that I'm getting slacked again. Okay, but I feel like this is something that a non-Rust noob would be able to figure out quickly. I'm just kind of gonna beat my head against the wall again until I figure it out. But I feel like that API should fully support it. So having mentioned that, the other thing that I'll mention is just the transaction API itself. So it's super simple. Like I said, like most of the code is in this draft PR is in this test. The API for creating a transaction, what I have right now is I just have a create transaction method on the Delta RS Delta table struct, which returns a Delta transaction. And it really only has one method so far, which is commit all. And it expects you to pass all the actions that need to be committed as part of the transaction. I feel like this separation is good. And what we really want is for the Delta writer to basically return the appropriate action based on whatever record batch was written to it. So we have a decoupling here. So basically, it would be the responsibility of the caller to instantiate a writer and a transaction, write to the writer, get back the actions, and if it's doing any sort of update, merge, or anything more complex than a peer append, which, to be really honest, it's only the peer appends that I care about for my purposes. But if it needs to do any adds and removes based on an update, for example, then it would be responsible for collecting all of the actions that need to be committed to the transaction when everything is done. One notable thing here is the whole concept of the transaction is when you go to commit, the transaction should be capable of checking basically the snapshot that's represented by the Delta table it was initially instantiated with against whatever snapshot might exist after the transaction was created. And so what I have right now does make assumptions that the caller will do all that management. So basically, the caller would be responsible for making sure that only a single transaction context exists at a time, or rather, let me rephrase that. That a single transaction instance refers to a Delta table which contains and represents the snapshot. And then basically pulling and diffing whatever the later snapshot might be against that. Ultimately, we need to have conflict resolution internal to the transaction, which could check the current metadata against whatever metadata was present when the transaction was started. And actually, when I say metadata here, I actually mean more than just metadata. Metadata as well as new files added to the Delta log. That part's not implemented, so this is really, and so back to the naive part, this first implementation is essentially assuming a single writer against the table. So if there are any other writers, which there will be in my use case, then we're going to need to do conflict resolution during the commit, and that would be handled inside of this commit all. So does that make sense to everybody, the way I said it?
Yeah.
Yep,
Makes
makes
sense to
sense.
me. I mean, it's interesting because if you go back to that portion where you create a transaction and then you add, and then after that, when you commit the transaction at line 372, I don't know if it would be an anti-pattern or not, and I'll make this comment on the pull request itself when I look at it. But it would be interesting if where you write record batch in line 366, instead of returning that add, you could potentially also pass the transaction a mutable reference to the transaction as part of the argument. So metadata record batch and then transaction, and then what would happen there is instead of returning the add action back, you sort of append it to the transaction internally, because requiring the user to specify the actions, in the correct sequence could cause conflicts on its own. So what then we do after that is that we just commit all to the transaction without passing the vector, because the transaction would own the vector of actions inside of it. So I think this gives us a good start to explore, usability of APIs. I don't like creating a flow where we require someone to do non-trivial work, because sometimes, if you don't remember to add the right transactions, etc., in the right order, it might cause issues.
Yeah, that makes total sense. And to be honest, my kind of longer term view is pretty similar to what you're describing. However, I kind of have a split in my own mind. On the one hand, I was thinking it would be nice to kind of maintain a vector of actions on the transaction itself. But on the other hand, I'm also thinking that as Delta RS continues to evolve, there will be more layers on top that maybe should have this like fine-grained interaction with and be capable of storing their own actions as they're doing each step. So for instance, I'm thinking that Delta RS should have a concept of an update command, which would, that update command would encapsulate the process of creating whatever adds need to be created, as well as whatever removes need to be created. And so they would, so those update commands would still be in Delta RS, so it wouldn't go out to the ultimate user to manage. It would be encapsulated in Delta RS still, but the kind of the parts would be out on the floor for Delta RS for those higher level commands to use as they see fit, rather than kind of tying everything to use to kind of tuck all their actions into the transaction as they're going along. I don't know. I haven't thought through it enough to be strongly opinionated on which way makes more sense to me. But that was kind of part of what was feeding my hesitancy to add that action vector to the transaction right out of the gate, if that makes sense.
Yeah, that does. I suppose I also need to look at the Delta specification in more detail. I think I looked at it like 2 months ago, just skimming through it. But now's probably the time to sit down and read it properly. Yeah,
like so the thing is, like, an update is actually pretty complex, and this does not, this test does not fully if as you're going through the PR, you'll have to read the comments, because this is actually not a legitimate update. A real update would rewrite the initial add file, and I'm not doing that right now because that requires like reloading the initial file, scanning for only the rows that have a change in them, and rewriting a new file that contains all the unchanged rows and the changed rows together, removing the old add, and then including the new add that includes the rewritten rows. So I'm shortcutting that just for the sake of the test. But yeah, it's when I'm looking at the reference implementation, I really like the layered approach they have, where they have the transaction is very decoupled from the log itself, and then the commands are decoupled from either of those, and they kind of use them in a compositional way. So you have this concept of an update command that creates actions and writes data as it needs to, and then commits the transaction in one shot. But I mean, I don't know how closely we really want to match the reference implementation. I'm not trying to match the reference implementation, but there are some good ideas in it.
Cool. No, I follow.
I have questions. Is the PR ready for review? I saw that it's still in draft state. So should we start reviewing it now?
Yeah, so I put it in draft. I think the only thing that I absolutely want to do before I consider it mergeable is I at least just want to rebase, because I got a bunch of sloppy commits in there. So I'll do that real quick, and I'll put it in official PR status. And we can go from there. Yeah, so I'll just do the rebase, but that's not going to change any of the code. So yeah, feel free to start reviewing.
Cool. I think a lot of those discussions we just had, we can have that in the GitHub.
Yep. PR. Perfect.
With the context of the code, that will be a bit more helpful to understand.
Yeah, also agree.
What was that, Neville?
Oh, sorry. I was saying I also agree with that. Yeah. With
okay.
What Keith was saying.
Yep. Gotcha.
Yeah, I don't know. I think that looks pretty cool to have a media demo on the write support.
Nice. Cool. All right. I think that's everything I need to talk about here, since we'll just carry this on in the PR discussion. Any other things we need to talk about before we adjourn?
Nothing
Not-
from my side.
Yeah, not from my end. Anything? I guess, yeah, I think that's all then.
Cool.
Right, I can ping Tyler and then we can end the stream.
Awesome.
Okay.
All right. Thanks, everyone.
Bye.
Cool. Cheers.
Talk to you in 2 weeks. Bye.
Okay.